Now we're going to have Andreas Geppert talk to us about replication resiliency.
Thank you very much. Thanks for coming to this somehow difficult slot after the lunch. I hope I can keep you awake. So I'll talk about a special use case of logical replication in a complex setting where we run database platforms across different infrastructures or infrastructure clouds. A few words about myself. I'm a database platform architect and engineer at the Zürcher Kantonalbank. If you don't speak German, please don't try to pronounce that. You might never have heard about ZKB, but ZKB is actually the second largest bank in Switzerland, after the former second largest one went belly up. It's also the safest commercial bank in the world, according to the Finance Forum, which published a report earlier this week or last week. I'm also the vice president of the Swiss Postgres user group. We organize the best Postgres events in Switzerland, like the CERN PG Day, which will take place again February 6th, and the Swiss PG Day, which is actually 2 days in June next year as well. So please save the dates. Good. What's the context? Our company is moving applications to the cloud, to the public cloud. We have a large footprint on-prem, mainly Oracle databases, a few SQL Server, a couple of still mainframe DB2, but no Postgres. In the cloud, the only supported standard database is Postgres. Since 2022, we are building up a DBaaS, a managed Postgres offering on top of the cloud providers' Postgres offering. And that was actually a strategic decision, even before I joined the bank, to use the cloud provider's managed service, platform as a service offering. That is a relevant fact, and we'll come back to that later. So what we do is we provide Postgres databases and services to our applications on top of the managed service of the cloud provider. So what the cloud provider gives us is you can provision Postgres servers there. They implement backup and restore, disaster recovery. You can have an HA setup. But basically what you get from them is a Postgres server. And from an application point of view, you can still do a variety of things. And if we would hand out the servers to the applications directly, you would end up in a pretty big chaos. So that's where we come into play. Our added value is that we provide database as a service. So if an application needs a database, a schema, user roles, if they want to copy data from one database to another, that's what we do. We automate as much as we can do and provide these automations then as self-service to the applications. So that means we currently have 85 Postgres servers across 3 environments, test, dev, and production. We support currently 109 applications. There arrive new ones every week or so. And we have 600 databases, so we have a model where we can share servers and put multiple databases into one server. But we can also support, if the application needs it, we can also support dedicated Postgres servers. So 600 databases, and they contain 1150 schemas currently. So the whole thing is growing. And everything or most of the applications that end up there have migrated from Oracle. So now what happened is maybe 1.5 or 2 years ago, There was a security audit, a bigger audit of the entire cloud so far, and they came up with a requirement on obligation that we have to keep copies of the data in Postgres databases, at least for the critical applications, with a maximum data loss of 15 minutes. So that means recovery point objective is 15 minutes, and that's why the code name of this project was RPO 15. Critical application means there are risk assessments of applications, which then apply to the database as well, in terms of availability, integrity, and confidentiality. Relevant here is the availability rating, and the risk is assessed in terms of what's the financial impact if something happens. How much money do you lose if you don't have your data anymore, for example. There are 4 classes, A, B, C, and D, and the classes here in scope are A and B. There are roughly 60 applications in ZKB that are A or B. Not all of them are on Postgres yet, or even have databases yet, but a few already are. Good. So we looked into that requirement, and I should mention that was a show-stopping requirement. So if we didn't manage to satisfy that requirement, address that obligation, the cloud journey would have stopped at that point. Of course, non-critical applications could still go, but when people understand, they don't really support the critical applications, then if nobody would move. So RPO 15, the requirement was the data has to be available outside the cloud in something that is not managed by the cloud provider. Could be a different cloud, could be on-prem, but we were still obliged to use the cloud provider's past offering. So going to a different offering would be a very long-term thing, so it was not so easily possible in order to satisfy the first 2 requirements. Then the last 3 requirements are related to the application. It shouldn't be the case that we break automation, the automation that we have. The whole thing should be transparent for applications. There should be no additional burden on the applications to satisfy that requirement. And the existing deployment mechanisms, which are very flexible and agile, you could say, should be possible as well. And we will go into the details there later. So if you're confronted with these requirements, there are solutions that immediately come to mind, like physical replication, for example. And so we assessed them against the requirements. Let's go through them. So what you immediately would think solves that problem is physical replication to the outside cloud or continuously back up the WAL files. That would solve the problem easily. Actually, physical replication is supported by the cloud provider. Our HA setup relies on that. Our DR solution relies on that as well. But that is restricted to physical replication within the cloud. But physical replication to outside the cloud is not possible. It's not supported. And they also do backup. We use the point-in-time restore very frequently whenever we copy data. There's a standard process where we do that. So they do backup and restore. They maintain you can even see which snapshots they have. But you can't access the WAL files, the WAL backup. So that's not a solution either. As long as we stick to the path usage of the cloud provider, these 2 options are not applicable. So we could replicate physically to a different region. That's supported by the cloud provider, but it doesn't meet the requirement that the data copy has to be outside that cloud. It would still be within the cloud provider's infrastructure, just in a different region. So that's not a solution either. Then a clever manager asked, yeah, we do PG dump. Why do we not just do PG dump every 15 minutes? Okay, yeah, it's a management question, and you have to try to come up with a polite answer. I mean, our databases are not yet, we have a few very big databases in the terabyte range, but the databases in scope here are smaller, but they are not so small that PG dump would work every 15 minutes. So that means we are running out of options. Now the last one is logical replication. Initially we ruled it out because it was clear it does not support, it does not replicate DDL, and it would have an impact if, yeah, we expected a pretty much impact on applications. So initially we ruled it out, but after all the other options were not applicable, we returned to logical replication, but it does not replicate DDL. But it turned out that there we can do adjustments and we can make it work, and that's what the rest of the talk is about. There is a presentation by these two guys. There's already a patch and a presentation where they describe how you could replicate DDL as well, how it would look like, but it hasn't found its way into the core yet so far. So we use logical replication from, and that's supported. The cloud provider does support it very well. So we define logical, we set up logical replication relationships on a schema level. So sometimes, often applications have multiple components, which means multiple schemas. Some of them, and the components can have individual availability ratings. So in case the application itself is critical, but one of its schemas is not critical, we would not replicate it. So we replicate on schema level. So per publisher, we set up one subscriber as a general rule of thumb. The setup of the subscribers, that still involves a few manual steps, but that's also not very time critical. And as soon as the subscriber is set up, we can establish logical replication relationships pretty much in an automated way. So basically what you need to say is, I want to replicate this schema in that database in that publisher to that database in that subscriber, and then the replication starts. We monitor the whole thing with PGWatch too, and also do alerting. I have separate slides about that. And we have an API to manage an already running logical replication, and that will then be provided as a self-service to the applications. I mentioned already everything there. Good. Now, whenever replication is running, things might happen. Certain events might break the replication. And what we typically see whenever the provider does maintenance, I mean, we can tell them a maintenance window when they can do maintenance. And for production, we tell them, yeah, you can do maintenance on Sundays between 6 and 7. And that means then on Sunday between 6 and 7, they break our logical replication. So sometimes when they do maintenance, I mean, they don't break it willingly, of course. But sometimes when they do maintenance, that involves a failover, and that because we are before, our versions are older than 17, they're mostly 15 and 16. And that means you lose, during the failover, use the replication slot, and the replication then stops. So that's one case. Sometimes we do have connectivity issues, and depending on how long they take, replication stops as well. In principle, we define logical replication to disable itself after the first apply error. So whenever there's a connectivity issue and replication can't be done anymore, the subscriber sees an apply error and then disables itself. And then we can also have application schema changes on the publisher side, and that would also very likely break the logical replication. So what do we do? As I said, replication is disabled upon the first error. We monitor that. You see it goes between 0 and 1, because for each single replication there cannot be more than one error. Because whenever we fix it, we reset the statistics. I took an example where we had, because normally, I mean, it's just flat on the 0 line. So I took a screenshot where you see some errors. We also have an automation that checks if individual replications do have apply errors, and whenever we see one, we try to enable the replication again and to start it again. If that's not possible, the alert would kick in, and we admins or the on-call staff would be alerted. We also monitor the wall accumulation on the publisher side, because if replication is disabled and is stopped, wall accumulates on the publisher side, and if that happens, the storage might run full on the publisher side. And in addition to not having the replication going on, then even the publisher might stop working or go into read-only mode, and then even the publisher is not available anymore. And for something that should give you more resilience, that would of course be a bad outcome. So that's why we have a specific look on, or specific focus on the WAL accumulation of the publishers on the cloud side. Good. Then the next possible thing that could happen is that applications change their schema. Applications have grown used to being able to change schemas frequently or anytime when they want. I mean, there are certain times, but it's not like in the past where you had one release window every quarter or so, and you had to stick to them. So that's out of the question. And they don't want to be restricted when they do their changes. It's also not possible to shut down the application to do only DDL changes first, which would allow us to do the schema changes on the subscriber first and then on the publisher, and then bring up again the application. That's also not possible because they don't accept this downtime on the application side. But then that means we will have DDL happening on the publisher side, and that will not be replicated to the subscriber side. So we played around with event triggers and tried to replicate them via a separate channel, but that's too complicated. That didn't work out. So what we do is we automated we provide an API and a REST service, a REST endpoint for our applications where they can suspend and resume replications themselves. And if the changes are deployed via a pipeline, they can even include that in their pipeline. So what they first do is they would suspend the replication. Then they would deploy their new release, which might or might not have schema changes in DDL. And as soon as they are done, there's another endpoint where they can resume the replication again. And then the magic kicks in. So first we read the schemas on the DDLs on both sides from the catalog, and then we compare them. Before they were equal, now we check are there any discrepancies between the two schemas? Have tables changed? Are there new tables? Are there new columns? Have column data types changed? Are there new constraints? Have constraints been dropped? And we find out if the schemas now diverge. And it might happen that the application has released a new version, but it didn't change the schema then, because sometimes they don't even know. And then we just resume the replication, and it will pick up where it was disabled and apply the changes that have occurred since then. Otherwise, it's clear that the schemas are diverging, and there's no way to go forward except dropping the replication entirely, dropping the schema on the subscriber side, importing the schema, only the schema part, and then restarting the replication from scratch. And that means at this point we'll have a new initial sync going on. And that's probably the part that will, one of the two, I would say, aspects where it doesn't scale, because if the schema is very large and you have frequent schema changes, then you would do the syncing pretty often. And if the database is large, if the schema is large, data volume-wise, then you might also run out of that RPO15 window during that time. Good. That's what I wanted to show. With that approach, we managed to support that RPO15 requirement for our critical applications. We managed to avoid any real application impact. I mean that using the possibility to suspend and resume replications. It's visible to them, but it's okay, and they even can include it in their deployment automation. It might not be a very scalable solution, or it is not a very scalable solution. So if schema sizes, schema volumes get too high, then this is not a practical approach. But I mean, we thought the best thing we could do. But it still might be that use case might still be it might be an example for a general problem. How do you run databases or database platforms, like in our case, across multiple infrastructure platforms or multiple clouds? And that's actually one of the use cases that is also mentioned in the presentation about DDL replication. With that, I'm finished, and I think there's still time for questions and discussions.
How long it takes the initial sync with the largest database? Because you have the requirement for 15 minutes, but maybe the initial sync might take longer.
So far, not, no. I mean, you don't sync all of them at once, of course, and the databases or the schemas that we sync so far are up in the range of 50 to 100 gigabyte. So yeah. And also there's another question?
Yeah, I have two small questions. How do you handle sequences? And how do you compare the two schemas?
Sequences are also not replicated, yeah. I think that's the background of the question. I mean, currently we don't use the data on the subscriber side. It's just there in case we need it. So, and in case we would use the data on the subscriber side because we have lost the publisher, then the first thing is what we would do is set the sequences to some meaningful value here. How we compare the schemas, we read the catalog tables on either side, and then join them and find out, do we see something on one side which we don't see on the other side, or are there, yeah.
Thank you for the presentation. I have to the other side, please.
Okay, yeah, sorry.
I have a question about what went wrong with the event triggers approach. Could you please highlight more? You mentioned that you tried different ways to resolve, and you tried, among others, to set up event triggers, and you declined it. So.
Yeah. I mean, in case not everybody knows what event triggers do, I didn't know before we looked into that. You can catch DDL statements, and you can have triggers before DDL is executed and after. And then what we tried is to, I mean, there are different ways how to do it. What we tried is to store the DDL commands in another table, in a separate schema, and replicate that schema as well. You could try to use, to connect to the publisher side directly, maybe using foreign data wrappers, but that would have meant that we connect from the cloud to on-prem, which is not so okay with our security people. The problem in the end is that you would have to make sure that you are applying things in the same order on the subscriber side, and that's something you cannot really guarantee. So, I mean, on the publisher side, and things are happening in one transaction on the publisher side, and they will not happen in a single transaction on the subscriber side. That's one problem. So that means you're changing stuff structurally on the publisher side, and immediately afterwards, probably, or maybe you're performing data changes based on these structural changes. And you would have to make sure that you have the same order on the subscriber side, and we saw that this is not possible.
Any other questions?
Thank you for the talk. While you're pausing replication for these deployments that may or may not contain DDL, is there a reason that you don't just apply safe DDL changes to the replica instead of having to do a drop and resync?
Why we pause it?
No, not why you pause it, but why don't you apply that same DDL to the replica if it's safe to do, like not a drop, but say a create index would not be logically unsafe?
Yeah, but in general, we don't know what the applications do. I mean, that was one thing we looked into. If we can tell the applications, you shut down the application, so there are no data changes that would have to be replicated. We perform the DDL, and that has to be DDL only. And we first apply it on the subscriber side and then on the publisher side. And then we bring up the application again, and then data changes start happening again. But that's not compatible with their release approach. And also the scripts that they apply, that can have DDL statements, but it can have data changes as well. And then you run the problem that if you run the same scripts on the subscriber side, you do the DML once, and then you get it again via the replication. So in the general case, guaranteeing consistency is not possible.
How do you intend to scale this as your data grows beyond a resync being like performant and quick?
There are no real good answers. I mean, otherwise we would have done it already. I mean, one option certainly is that DDL will be replicated in an upcoming version. I've heard that you shouldn't wish features or so from the community, because then the answer will be, yeah, why don't you get involved? And but that's certainly one option. The other option is that we have to compromise one of the requirements that I showed. But we are now in a position where we can argue with the management. We have done what is technically possible, and that is limited. And it bought us a lot of time. We could continue our cloud journey, but as soon as we have bigger databases, as soon as applications create new partitions every day or so, or every hour, that will not work anymore. But yeah, I mean, it's often people ask me, well, why do you have that strange requirement? But I think it's a bigger context. How do we handle? I mean, I want as a Postgres person, I want to be able to run my database platform, and I want to stretch it across infrastructures and I want to stretch it across clouds and on-prem easily. And how do I do that?
Unfortunately, we are out of time. Thank you very much. It was a really interesting talk. Thank you.